start again. It's a rich thing.
So our next data type is set. It is also a sequential data type where you can store multiple items within a single variable. Now first of all let me define a set. To define it we need to give a name. So here I am giving it s, and then within curly braces you can store any value. Like you can store an integer value, or you can store a float value, and also we can store a string like this, and then you can also store a tuple within it like 1 comma 2 comma 3, and that's all. Now you can check the type of s, so it will be showing set like this. Let's understand different properties of a set. For example, set is unordered, which means it doesn't has any specific order. So if you try to print this set, then there is no guarantee that it is going to print in this order only. So let me print it. So note that the order has changed. So the next property is duplicates are not allowed, which means set doesn't allow duplicates. For example, here we have a set S, and within this set we have 10 three times. So now if I try to print this S, then it will automatically remove the duplicates. So let me print it, print S. Now note that here we have 10 only one time. So the next point is indexing and slicing concept is not applicable. Now if you try to print this element by using slicing concept, then it will raise an error like s, and within square bracket if I pass the index of this 6, that is 0 1 2 3 4, then it will raise an error like this. Set object is not subscriptable. Set is mutable, which means you can add a new value after declaration, and you have different methods to do it. So here we have a set s is equal to 1 2 3 4, and now if you try to add 10 within this set, then you can write s dot add, and within parentheses you need to pass the new value, that is 10. And now if I print, so it is showing the updated set. Now let's understand different methods that are applicable on set data type. Now here the first method is add. So already we have seen it, but let me show it again. This method is basically used to add new value after declaration. So to add a new value we need to write s, the set name, and then write the method name, that is add, and then within parentheses we need to pass the new value, that is, for example, here I am trying to add 10, so let me pass 10, and now if I print the s, so it is showing the updated set. So our next method is copy. It will create a copy of a set, after which you can use this new name to use this set. For example, if I write p equals to s dot copy, and now from onwards you can use this name, new name p, to print this set. For example, if I write print p, so this is our output. So our next method is clear, and this method will remove all the elements from a set. For example, if I apply this method on this set s, like s dot clear, then it will remove all the elements, and now if I print the set s, then it will return a empty set like this. So our next method is discard. It will remove one element from a set. For example, if you try to remove this 4 from this set, then you can use this discard method. To use it, we need to write s dot discard, and within parentheses we need to pass the value, that is 4. And now if I print s, so it has successfully removed this 4. So our next method is intersection. It will return a set where we have the intersection or the common elements from two sets. For example, here we have two sets, and the common elements between two sets are 3 and 4. So if I apply this method on these sets, then it will return 3 and 4. For example, if I write a dot intersection, and then within parentheses we need to pass another set, that is b. So it is showing 3 and 4. So our next method is union. It will return a set where we have all the values from two sets. For example, here we have two sets, and if I apply this union method on these two sets, then it will return a set where we have all these values. So a dot union, and within parentheses we need to pass the another set, that is b. So this is our output. So our next method is disjoint. It will return whether two sets have intersection between them or not. If there exist any common elements between two sets, then it will return false, otherwise it will return true. So we have these two sets, and here these two sets have some common elements that are 3 and 4. So if I apply this method on these sets, then it will return false. So let me do it. A dot is disjoint. So it is showing false. So our next method is superset. It will return whether this set contains another set or not. For example, here we have two sets that are A and B, and all the elements in B can be found in set A, that is 3, 4 and 5. So if I apply this method on these sets, then we will get true. Like if I apply A dot is superset, and then within parentheses if I pass the set that is B, so it is showing true. So our next method is subset. It will return whether this set is a subset of another set or not. For example, here we have a set B, and this B can also be found within this set A. So this B is a subset of A. So if I apply this method on B, like B dot is subset, and then within parentheses if I pass A, then it will be showing true, like this. So our next method is remove. It will remove the particular element. For example, if you want to remove this 4, then you can write A dot remove, and then within parentheses you need to pass the element that is 5. And now if I print A, so it has successfully removed this 5. So our next method is pop. This method will delete one element randomly, and it returns that element. So if I apply this method on set A, like A dot pop, then it will remove one element randomly, and let me store that element in B. So now if I print A, so note that it has removed 1, and this 1 is stored in B. So let me print B like this. So our next data type is Frozenset. As the name suggests, it is frozen, which means we can't change the value after declaration, or you can say it as the immutable version of a set. Now we don't have any facility to declare it directly, so we need to first declare a list or a set, then we can typecast it into Frozenset. So here we have a list, and let me declare a Frozenset. So f equals to Frozenset. You need to use this function, that is Frozenset, and then within parentheses you need to pass the list, that is s. So now if you check the type, then it will be showing Frozenset like this. As it is the immutable version of a set, so we can use all the methods on Frozenset that are applicable on set, except those methods which modify the value, because Frozenset is immutable. For example, add method adds one element, which means it changes the value. So we can't use this method on Frozenset. For example, here we have a Frozenset that is p equals to like this 1 2 3 4, and if you want to add one element by using add method, then you will get an error. For example, if I write p dot add 10, then it will raise an error like this. Frozenset object has no attribute add. But isDisjoint method only checks whether there exists an intersection between two sets or not. It is not going to modify anything. So we can use this isDisjoint method on this set Frozenset data type. For example, here we have two Frozenset that are p equals to 1 2 3 4 and q equals to 3 4. So there exists an intersection. So if I apply this method on this Frozenset data type, so we will get false. So let me do it. P dot is disjoint, and within parentheses if I pass q, then it will print false like this. Here I want to mention one more thing, that is if you want to declare an empty set, and if you declare it like this way, then it is not going to consider as a empty set, because if you check the type, then it will be showing dict. So what you need to do is, if you want to declare an empty set, then you need to write s, and then you need to write set, and then like this way. If you declare it like this way, then it is going to consider as a empty set. Now you can check the type. So it will be showing set like this. Now this is all for this video. If you want to download the lecture notes, you can join our Telegram channel, link is in the description.